Hello everyone, this is Dr. Lennon and I'm here to walk you through the test 2 review. So I've posted this as a new homework assignment to help you study for the test, and a reminder that the test will be available from I think 6 a.m. to 5 p.m. On Thursday, November 15th, and what you can do is you have 2 attempts to complete it. And I'll show you what that looks like. So it'll be available under this quizzes and tests tab at that time tomorrow. So the review is going to be pretty similar to the questions on there. So let's have a look. So let's go through. There's 12 questions here. The first couple are on the topic of a z-score, which is describing, based on a distribution, how many standard deviations that an observation is away from that. So let's have a look. Let's just remember the definition. So if you have x as an observation, say mu is the population mean. Sorry, I haven't written with this in a while. And sigma is the standard deviation of the population. Then the z-score of that observation x is found by computing x minus mu divided by sigma, and it tells you how many standard deviations away that observation is. So let's have a look. Whoops, we're on the second tab. So this one says, suppose your professor reports test grades as z-scores and you got a 2.2 on an exam. Write a sentence explaining what it means. Well, it has nothing to do with the mean. As we mentioned, it has to do with the standard deviations, and because it's positive, it's 2.2 above. So this would be A. All right, let's look at the next one. So the next one, we have a music library, and the mean of the songs, I suppose, is 249.7 seconds, and the standard deviation is 113.58. And we want to find the z-score of a song that is 400 seconds long. So again, we're going to do the z-score with that, so you might want to have a calculator handy, but you're going to do the observation, which is 400, minus 249.7, and then divide that by the standard deviation of 113.58, and that will give you a value of 1.32 if you round. So if you want to see that over here, in this case, that would be z would be 400 minus, let me see, what was the value? 249.7 divided by 113.58, and that comes out to value of 1.323, something like that. But we're rounding to 2 decimal places, so we'll just stick to 1.32. So that's the z-score. All right, on to the next one. So the first two pretty straightforward. The next one, I believe we might be moving on to the empirical rule. Yeah, so this is the 68, 95, 99.7 rule. So we have a mean with a diameter of 10.6 inches and a standard deviation of 4.4 inches. And what you really want to do is figure out the tick marks on the bottom. So what you're doing is just adding and subtracting multiples of 4.4 to 10.6. But if you're a little bit lazy, there's a way to do that in StatCrunch. So if you go to Question Help, StatCrunch, sorry, my computer's behaving a little slow today for some reason. All right, here we go. So what do we looking to do, well, what we're going to do is we're going to open up the normal calculator. So you find that under Stat, Calculator, and then go down to the normal calculator. So this is the normal distribution. So what you do is you can fill out the mean that they said was 10.6 and the standard deviation of 4.4, and just compute any probability. So let's say the probability were less than 10.6. That doesn't really matter for us. What we're trying to do is just find above where it says 68, 95, 99.7 ticks, and it'll show you exactly what the mark should be on the bottom when you're trying to do 68, 95, 99.7 rule. And so the one we can toss out immediately is B, because the middle is 15 and the mean is 10.6, so it should be there. And then if we're trying to distinguish between A and C, C has 99.7% of the observations occurring between 1 below and 1 above, and we know that's wrong. 99.7 needs to go from 3 below to 3 above. It should be 68 within 1 standard deviation of the mean. So the correct answer here is C. All right, so then we want to figure out, using the 68, 95, 99.7, the central 95% of the diameters are between which values? Well, 95 is 2 below to 2 above, so if we look at the correct one, C, we can see that that is 1.8 to 19.4. All right, it says what percentage should have below 1.8. And again, the thing that you might help you figure out the thing here is you want to remember all the different portions. So essentially when you're doing 68, 95, 99.7, you've got a normal curve, and then you've got your middle value, and it's supposed to be perfectly symmetric. So there's kind of 4 separate pieces on one half or the other. It doesn't really matter which half, but essentially this piece right here is half of 68, so that's 34%. The piece right next to it is 1/2 of 95 minus 68 divided by 2, using the symmetry argument, if you remember from class. So that comes out to 13.5%. And then this piece right here, same way, we found that that was 2.35%. And then the tail at the end, this little bit, is 0.15%. So we can just add together whatever the appropriate numbers are whenever we're trying to figure out things using the rule. So on this one, we want to know below 1.8. So that's the 2.35 piece right here, plus the 0.15 piece, that's the tail. So that, when you add those together, you get 2.5%. All right, and then we want to know between 19.4 and 23.8. So 19.4 to 23.8, that is, so this is the 34 piece. All right, then the 13.5, and then down here 19.4 to 23.8, that's the second smallest piece, 2.35%. So that one's going to be 2.35. All right, then the last one, what percentage should have over 23.8? So that's the very end, the very smallest piece, 0.15%. All right, so now we're on to conditional probabilities. So a lot of these are done, these are pretty simple, the card ones. So you just want to consider what the group of things you're looking for out of what specific subgroup of the entire deck. So we're looking for the fact that we want to know what the probability that we have a diamond, given that we know the card that we drew is red. So if you had a red card, what are the possibilities? Well, there's only diamonds and hearts. So that would be 1 out of 2, or 0.5. The one thing that's interesting here, they do want it to be in terms of the lowest term fraction. So if we answered on that previous one, say 13 out of 26, because there's 13 total diamonds out of 26, it'll mark it wrong. So you want to put 1/2 there. So simplify your fractions if you think about it a little bit differently. The card is red given that it's a diamond. Well, if it's a diamond, all diamonds are red, so that's 100% probability. Okay. Now the card is a 10 given that it's red. Okay, so half the deck is red, that's 26 cards. And out of that group of red cards, there are exactly 2 10s. The hearts, the 10 of hearts and the 10 of diamonds. So that's 2 out of 26, but we need to make sure that we simplify that fraction. So we're going to answer 1 out of 13. And then the card is a jack, given that it's a face card. Well, there's 3 types of face cards. Kings, queens, and jacks, and there's an equal number of all of those. So jack is one of those possibility out of the group of those 3 things. All right, so on this one, essentially what we're doing is we're looking at this table here, and it's a two-way table, so we have 2 different things. We have blood pressure and cholesterol. And in each cell, it's indicating a pair of those. So you could either have high blood pressure and high cholesterol, or high cholesterol and okay blood pressure, or vice versa for all the different possibilities. So if we're looking for what is the probability that a man has both conditions, so again, the conditions that are looking for are high and or high blood pressure and or high cholesterol. So in this case, that is 0.17, high for both. All right. What is the probability as high blood pressure? Well, there's 2 possibilities for high blood pressure. He could have high blood pressure and high cholesterol, 0.17, or he could have high blood pressure and okay cholesterol, 0.13. So if you add the 2 of those together, 0.17 plus 0.13, you get 0.3, which would be the total answer here. Okay, so then the last 2, C and D, are actually conditional probabilities. So C asks, what is the probability that a man with high blood pressure has high cholesterol? So essentially we're asking, what's the percentage that he has high cholesterol, given that we know he has high blood pressure? Well, the group of all people with high blood pressure are 0.17 and 0.13. And out of that group, only 0.17 have high cholesterol. So what we have to do here is essentially we have to do, so we're doing the 0.17, those in that group that actually have high cholesterol, divided by the total 0.17 plus 0.13 that has high blood pressure. It's kind of like you could imagine it this way. So we had a group of 100 people, a total group with all 4 possibilities, and we said, okay, let's take the 30 people with high blood pressure, then what percentage of those have high cholesterol? And that would be essentially 17 out of 30, which is what we're computing here. So we can put that into the calculator, and we get 0.17 divided by 0.3 gives us 0.56 repeating. Whoops, lost track of my mouse there. 0.56 repeating. So when we come back to this one, we're going to answer 3 decimal places, so 0.567. And then D is similar. D, we're doing the probability has high blood pressure, given that he has high cholesterol. So those with high cholesterol are in the top row, 0.17 and 0.23. So for this question, we're looking for the high blood pressure out of the group of that top row. So that's going to be 0.17 divided by 0.17 plus 0.23. So just punching that into the calculator, and you get 0.23 exactly. Oh, no, sorry, I made an error there typing it in. So 0.17 divided by 0.17 plus 0.23, and that will give you 0.425. So we can enter 0.425. Okay, so that's it for part 1. It may take me 2 more parts to finish, but I I will get back to you in the next